Okay, having just finished doing the 2022 papers, the one thing that was really obvious was this is a really easy one. There was only two questions, one that I kind of stuffed up initially because I just wasn't thinking straight. It was question 16 and question 18, the only ones that were a little bit more involved. The rest were pretty straightforward, if not extremely straightforward. So just starting here with question 1, melting's a pretty easy one to start with. So physical change, obviously melting's physical change. The other one is it's reversible. It's almost like I don't need to analyze this one. There's just so little in that one. Of course, it's not a chemical change. It's not even a... Okay, it's not much to say there. Okay, ease you in. Can't see me marking off that page. There we go. Most of them are pretty easy, so just use the timestamps to skip ahead as you need to. All right, so question 2, intra-chain. I don't like these things when they're dealing with amino acids, but it wasn't much of an issue anyway because there's not many choices. So they're really all intra-chain, even though the tertiary is often called intermolecular. It is actually the same molecule, so they're all actually... interchain, I guess, intra-chain. Can't be primary because that's a sequence of amino acids. Certainly can't be quaternary because that's just adding extra strands, different proteins, or the same protein, several of them. So the tertiary one is a little bit, really it's interchain, but it really is this intermolecular, intramolecular. So the secondary is more so. All right, so they're obviously talking about alpha beta chains there, that's all. And that's within the chain itself, staying away from the intermolecular, intramolecular terms. Okay, question 3. That one I've sort of just jumped to knowing what's going to be on either side. So I'm just drawing this out just to make sure I don't stuff up the terms that they've used. So they've used positive and negative. So just labeling them all. So if it's electrolysis, electrons are going down this side. That's a cathode, reductions occurring, you're gaining electrons. I needed to put a beaker in there just to show the copper, so I made that a bit smaller. I think there were electrodes to start with, and I just thought it started looking galvanic. But anyway, so the copper is going to come off at the positive and join to the negative. And so I can basically get rid of the copper one. Sulfate never reacts. And so you're left with water. So water will hydrolyze. So the negative bits go to positive, and the H plus is positive bit goes to hydrogen on the other side. So there's no real choice there. The hydrogen will go the other side. Copper's not doing that. Sulfur's not doing that. So not too hard because you don't have to do any equations or numbers. You just have to just give the general gist. All right, so still pretty easy. All right, as I said, wait till you can jump to 16 and 18 if you want. Okay, so question 4, hard water. I always like to just draw a quick picture just so I don't do anything silly. I can see it's all talking about calcium ions there, and so calcium ions will stick to the negative bit. Okay, so the hydrophilic bit is the negative bit, hydrophobic bit. So A looks correct. Hydrophobic, no, it's going to be no interactions with hydrophobic, so I can cross out 2 hydrophobics. Hydrophilic is not going to form insoluble fatty acids. So it's going to form a salt because it's positive and negative. So metal plus non-metal is a salt. Okay, question 5. This one's pretty easy. It's concentrated and weak. So just go through and cross out the appropriate questions. So C is the only one that's concentrated and weak. All the rest are different combinations. That's 5 done. Okay, question 6. Things that are going to gain electrons will be on the right-hand side. So halogens and anything else. Noble gases won't work. And the metals won't work. Not much to say, so it's like question 1. That's just a little bit too straightforward. I think they found this test so straightforward. That's why I made the 2022 test a lot harder, so they can put people on a bell curve better, basically. We'll see what paper 1 and 2 short response is like soon. All right, amides, you just got to carefully check these ones. There's no oxygen there, so A and B can't be correct. C looks a little bit confusing. I don't know what that oxygen there is. Looks, because there's an amine over there, that looks like an amino acid. So the H plus has gone on to then H4. So that's fine. This one's the only one that can really make sense then, so it must be D. Okay, question 8 looks possibly scary, but the options are really not that scary. So acidic conditions, obviously there's acid in there in the electrolyte area. So just get rid of B and C altogether. Then you're just looking at the same thing here. Is the hydrogen present in the electrolyte, which it obviously is. And then that more confusing sentence is hydrogen given off. Now it's not really given off. It actually reacts to form water. So it's water that's given off. So the unused gas is basically stuff that hasn't gone through into the solution. So that's a very peculiar way of saying things. And hopefully that's how I'm interpreting that as incorrect. So it's coming out as unused because it didn't go in, and it didn't go into the reaction, then come off as a gas, then come out as unused gas. So it came in and then reacted to form water. So that's how I'm interpreting that question as the word given off. And so we're going to go for 8C. Okay, moving on to question 9. So we've got 3 things that are increasing in their boiling points. Increasing London dispersion forces is the reason. So what are our options here? We've got intra. It definitely has to be inter because they're separate molecules, so we can get rid of A and C. Then London dispersion is definitely London dispersion. There's no hydrogen bonding at all because they're alkanes. So fairly straightforward again. Okay, moving on to question 10. The equilibrium shift to the right. So I just draw an arrow just to make sure I don't stuff that up, and it's pressure on the system. So I want to go this way, and so I have to get less moles of gas on the right-hand side. Again, they didn't make this really hard. They could have put some solids and stuff in there to really screw people up. Maybe they should get me to write the test. So they're all really straightforward. D's like they're same on both sides. It's as bad as you can get as a distractor. You can make these tests way nastier. This is a really simple one, really. You can make this 10 times harder. So the questions are straightforward. The answers are straightforward. Enzymes act as biological catalysts because that's a negative. They lower the activation to positive. The rest are negatives. And D is not even true. That's just testing with the understand equilibrium constants, I guess, a little bit. So 11B, very straightforward. Moving on to question 12, green chemistry. Just looking for all the positives again. So you want to use renewable raw materials and minimize unwanted products, of course. There's unwanted reactants is another one. It's a strange one. Why would there be unwanted reactants? That doesn't make any sense. Just don't use them if they're not wanted. And then the last two are non-renewable raw materials. So you go 12A for that one. Just marking that off. And on to question 13. So this one's a little bit harder. You got to go to your data booklet. You got to look it up. You just got to be aware that the alcohols have separated. That the band around 3000. There's an alcohol band. There's an alkene band. Whereas the carboxylic acids are a bit closer. So it's one big broad band. So some people look at that straight away and they might think carboxylic acid. But I have to pull out all the different bands and just do a full analysis of it. So that one's around 1700 and 2900 around, plus or minus 200. So if I look that up, I think it's just easier just to write that out. So that's due to a carbon COO bond. And you can see that's for a couple of reasons. So I write those ones out. Hurry up with it. Write those ones out. Usually stuff to the right is a fingerprint. And it's a bit too messy to actually deal with. So the options are aldehyde, carboxylic acid, ester, and ketone. Now, here, the OH, so esters don't have an OH, so we can cancel out the ester. And the OH is to do with the carboxylic acid because it's overlapping. It's a big wide band. So I just draw in what you'd expect if you're going to see the alcohol one. It'd be above 3,200 because it's lower. So the 3,000, it'd be more of a separation, one for the alcohol. So it's not an alcohol. And so the ketone, there's nothing there for ketone at all as far as the OH is there. So the OH doesn't really explain the ester of the ketone. So you're left with just a carboxylic acid because there must be an OH group in there somewhere. All right. And there's not much there to deal with. So we'll just leave it there. All right. And so we're going to go for D. We need an OH group, and we're just telling between carboxylic acid and alcohol, basically. So mark off D on the sheet. And go to question 14. This one here, I always go back to first principles. I don't like to memorize anything. So Ka, well, if you've forgotten Ka, you can look at the data booklet. So it's products over reactants. And so if the Ka, for strong acid, it's going to completely dissociate. So reactants will go to products. And that means products will be low, reactants will be high. Therefore, Ka must be large for it to be strong. So I'm looking for the biggest Ka. I think they're trying to fool you with these negative numbers. So the smaller negative number is the bigger thing. So that's first, and that's the biggest. The -5 is the worst, and then that's the nitrous and the hydrofluoric, both -4, so 7's larger than 4. So that's how I've numbered them, and then they'll just give you B, so the rest are wrong. All right, so 14B. Okay, on to question 15. Organic just has the highest boiling point. So it's wise to draw them all out. I've just done a really bad skeletal here. So that'll only have London dispersion. This one has probably an aldehyde. So that's going to have a dipole. So that'll be better. This one there, now they're getting confusing. They've added an increasing molecular weight. So you've got to compete molecular weight versus better bonding. So that one is potentially confusing, but they clear it up by making D of the same length, actually even heavier with an oxygen as well, and then it's hydrogen bonding. So it's just in the end it becomes super easy. Not a lot to think about. Again, they could have made a way harder distractor for that one if they want to make the test harder and help spread people out on a bell curve, which is what I think they did in 2022. They made it way harder. All right, so question 16. This one here is the one I consider complicated. So in the end, I was just looking for what shortcuts could be done. So at the moment, I'm not aware of any shortcuts that can be done. I'm thinking there must be. So I'm just making sure I don't mix up things and put things in the wrong place. So I'm labeling this out with an amount of moles. Now, in the end, you'll see in the end it cancels out, so you can just leave it at moles, but that is a dangerous thing to do. So I'll explain in a second. So first of all, which one's limiting? So it's 2:1. This is 8:6. So I've done a few shortcuts there. So if we're using 8, then that must need 4 of the magnesium carbonate. but there's 6, which is excess. So the limiting reagent will be the ethanoic acid. So we know which one to work with now. So I'm pretty sure if I went and worked with the magnesium carbonate, I would have got the other distractors that I haven't cancelled out. So if someone's been lazy and they're just going to put 3.5 divided by the magnesium carbonate, the 8, that'll get the first distractor. It's probably, and I can't be bothered doing it, but if I got time I would, probably 6 over 3.5 over 6 and 3.5 over 6 is probably the other distractor. It's probably 44. That's probably what they're writing for the distractors. All right, so 3.5 over 8, can I, that's 47.5, but that isn't working out what is produced. So that certainly can't be correct. You've got 3.5 as the actual, and you have to work out what you're going to get. So it's the ethanol is 2:1, ethanol to magnesium ethanoate, and so that means 4 moles. Now, if you put 3.5 divided by 4, you'll get, that's a percent yield if moles works. So that'll get you the 88. So that's a good distractor if that's not the answer. Now we just need to check if we can actually use that as the answer. So if we convert both sides, both 3.5 moles and 4 moles into mass, which is what it should be, and then divide them by each other, if that gives you 87.5, well and good. If it's something different, well then that's the answer. So if you see, like if you work it out, so mass equals number of moles times molar mass, because it's both of them now need to be times by the same number, and this is all divide and times, then they do cancel out. So you can cancel out. If there's any pluses or minuses on here, on these division things, then you can't do it. So it's a bit dangerous if you don't understand the mathematical trick behind it. Otherwise, just work it out. So get the mass 3.5. So I'm just spending some time doing the molar mass, which is really annoying. I guess they don't want to show you what the molar mass is in the question, because that will give away information that will help students get the right answer. It's sort of a clue, or it could be a distractor. They should give you the molar mass of everything, maybe, because obviously you can see you have to do quite a lot of work to get this one out. They would be nice to save time if they put the molar mass in there and then just put the molar mass of everything. So it's kind of a clue, but you still have to know what you're doing. All right, so molar mass there is 142.3. So I can see that for both of these, I need to times them by the same number. So I was going to work it out to the mass. I'm thinking, I'm just wasting too much time. It's pretty obvious that both are times by the same number. So in the equation, it's not going to matter. Okay, so I'm just going to go ahead with 16C on that. Now, question 17. So this one here is a pH calculation. So we're dealing with hydrogen ion concentrations normally in water, 10 to the minus 14. So you've got Kw is hydrogen ions, hydroxide ions times together, it's minus 14. And so if there is H pluses, hydroxides in that form, you can just rearrange it. Now, I've done a bit of a shortcut here. So if the water has broken up, which it didn't really say that clearly actually, so it's a bit of an unclear question. I've made the assumption this is just water that's hydrolyzed. So the H pluses here, if you rearrange the equation, it must be minus 11 or somewhere near minus 11, and nothing else is close. So I've just gone for 17B without doing the full calculation on the calculator. So they could put much better distractors in there to force me to do the real number, but they didn't. All right, so now we're working up to the second one that I thought was tricky. Now, in hindsight, this is tricky because I just don't have the room to write everything out clearly. It's so squished, and then they've squished the molecules together too. So I spent quite a lot of time on this one. So obviously you need to write out the reaction. So you need to know what the answer is. So I've written that out, 2-methyl-butene. Now, Markovnikov's rule here is when the water gets in there, so adding the OH in there, the hydrogen's going to go to the most negative hydrogen, which is the carbon with the most hydrogens. And for some reason, I sort of wigged out and put hydroxide in there instead of H+, which I work out a little bit later. In the meantime, I'm trying to work out what exactly this A, B, C, and D are. Now, I'd like a lot more room so I could have a bit more room to write out the full structure because I've completely run out of space to write out answers. So I can see if I've got the right product or not. I'm thinking, well, maybe if I can write out the product and then condense it, I could do a much easier explanation. And this is still when I'm in the mind of putting the OH minus on the wrong side. All right, so the H plus goes to this carbon that would be the most negative, and the carbon that's the most negative, the ones with both hydrogens, because hydrogens give up their electrons and carbon suck them in. So that's what's going on as far as positives attracted to negatives is concerned. So I've written that wrong thing in here, which isn't too bad, because I just got to swap it around. It helps me interpret these a little bit better. So that one's just clearly wacko because it's got two hydroxide groups in there. So D's a nice one to get rid of. A is a nice one to get rid of because there's no OH there. So it's really between B and C. So I can cross out A. I don't quite know what that is. It looks like it's an ether, which is not in your syllabus. Can't be an aldehyde, must be an ether. So it's got to be wrong. Maybe it's a ketone. So C's correct. And then I'm just thinking, hang on, the OH can't be on that one. It must be on the other one. And the B and the C, that one there is just having the water on the other side, which is the correct side for it. So maybe it's not as hard. It's just that I wigged out at this question and put it on the wrong side. So hurry up and fix that up then. Yeah, I think I'm just sussing that one out. So just redo that. Goes there. That one goes there. That's the correct one. Recheck. So C can't be correct. That absolutely is wrong. That one's on the wrong side now, and this one's the same thing, but on the right side. So A and D are just out of the picture. And just being paranoid now and just writing that out because I've wigged out. So that's got me a little bit stressed out now. Now I'm doubly confirming it, that B does actually fit in with that pattern. All right, so I haven't written the CH2 in there, but I wasn't really focusing on that bit, so that one's not 100% correct either. Okay, so sorry for that one taking longer than it should have, but it is definitely the other harder one as well. All right, even if I didn't screw that one up. That's the second hard one. So the other rest are very easy. So just marking that off 18B. Going to 19. This one here, a catalyst. It's just what's a catalyst for? Lowers activation energy, increases rate of reaction. It's kind of silly. Doesn't do anything if it's an equilibrium as far. It does increase the rate of reaction, but rate of reaction on both sides, so it reaches equilibrium quicker. But that's not what we're doing here. We're just doing a straight, easy definition, really. So you can see even with the 16 and 18, they're not that hard. Certainly this part is very easy, this 2021 paper. This one here, looking for an ester linkage, so that's just writing that out just to be sure. So that's carboxylic acid joining with an alcohol. So I'm looking for that. That's the point. That oxygen's the point where it binds. That one's sort of taken it in the middle. There's no possible way that could be correct because there's an amide, so there's no ester forming at all. And D's got a carboxylic acid, so they're way out of the picture. This A is a reasonable distractor, but it hasn't got both functional groups in there, so it's sort of off to the side a little, and it's not encompassing the whole thing. So definitely B is the better answer.